All right, this is the review for the 5th 6 weeks retest. All right, we're going to go through the properties of exponents. The first one is the product property of powers, and what that says is if you have a term with an exponent multiplied by another term with an exponent, you add the exponent. So x to the a times x to the b is x to the a plus b. So if we look at these examples, this is x cubed, x squared, x, and remember that if you don't have an exponent on a term, that means the exponent is 1. So this is x to the 3 plus 2 plus 1, which is x to the 6th power. Here we have a slightly more complicated example. Remember that you put the terms with the things they go with. So 2 times -5. That's together. We have x to the 3rd times x to the 5th. And we have y squared times y. And when we do that, we get -10 times x to the 3 plus 5 times y to the 2 plus 1, which is -10 x to the 8th y to the 3rd. And this is your final answer. The second property of powers is the quotient of powers, which says if we are dividing terms with exponents, we subtract their exponents. So x to the a divided by x to the b is x to the a minus b power. So if you have x to the 5th divided by x to the 3rd, that becomes x to the 5 minus 3, which is x squared. All right, this is a more complicated example, and remember we group things together. So this is 2 over 4 times x squared over x times y to the 4th over y cubed times z. And there's no z on the bottom, so it just chills on the top. You could say z over 1, and you could just leave it on the top. All right, 2 over 4 simplifies to 1/2. X squared over x is x to the 2 minus 1 power. Y to the 4th minus y to the 3rd is y to the 4 minus 3, and then times z. And so this is really tiny, 1/2 x to the 1st y to the 1st z. Right there. There's the power of powers property, which says that if you have something with an exponent on it and you raise the whole thing to another exponent, that you multiply those exponents. So this becomes x to the a times b. So right here, x to the 4th raised to the 5th power is x to the 4 times 5, which is x to the 20th power. Here we have 3xy squared z to the 5th all squared, and so we have to square each of those terms. So this is 3 squared x to the, remember that's the first, right? 1 times 2, y to the 2 times 2, z to the 5 times 2. Again, because I'm getting those multiplications from this 2 right here, that's the 2 that's on the end. And then the exponent that was on your terms in the parentheses is the first number. The 3 did not have an exponent on it. Numbers will not have exponents on them in parentheses like this. What you do is you apply that exponent to the number, so 3 squared. Don't multiply the 2 and the 3. The answer is not 6, it's 9. So this is 9 x squared y to the 4th z to the 10th. And that's your answer. All right, zero exponent property. This is everybody's favorite property, which is that if you raise something to a power of 0, the answer is 1. Always, 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 always. 1. Always. X to the 0 is 1. And negative 15 x to the 12th, y to the negative 4th, z to the 4th, and h to the 45th quantity raised to the 0 power is also what, guys?
0.
Arturo, it's 1. Did I say equals 0?
Oh. Yeah.
Oh my gosh, guys, I'm so sorry. That's 1. Yes, you can. It's okay, guys. You're allowed to talk. It's 1. I'm so sorry, y'all. I don't know where that typo came from. Oh my goodness. Okay. Anything to the 0 power is 1. 1 is anything to the 0 power. So we're going to just write that just to make like triply sure that that 0 does not impact anybody. Anything raised to the 0 power is 1. Okay. All right. Good times. Let's talk about negative exponents, y'all. If you have a negative exponent, that is telling you that you need to move that term. It's telling you need to flip whatever is being raised to the exponent. So x to the negative a, that's like saying x over 1 to the negative a, and so that is 1 over x to the a power, like that. So what you do is, because this x was not part of a fraction, we throw it into the denominator of a fraction. That's what that negative exponent means. Now, if you started with 1 over x to the negative a, again, that negative is saying, hey, this is not where it's supposed to be. You need to move it. And so instead of putting this in the bottom of a fraction, it comes out of the fraction. It ends up being x to the a over 1, or just x to the a. So if you start with a term that's not in a denominator with a negative exponent, you throw it into a denominator. And if you start with a term that is in a denominator with a negative exponent, you throw it out of the denominator. It becomes a numerator. And in cases like this, it's just over 1, so it's just x to the a power. Okay, so here I have x to the negative 2, and so that just becomes 1 over x squared. It just is a denominator now. I'm looking at this one right here, guys. It's 2 over x to the negative 4. Remember that exponents only apply to the term that is immediately to their left. What is immediately to the left of the negative 4? The x. Not the 2, the x, right? And so that negative 4 only applies to the x. So what happens to the 2? It just chills where it is, right? So that negative exponent, that says, hey, put this in the top of a fraction, right? Or put it in a numerator. The 2 is already in the numerator. So this becomes 2x to the 4, okay? Because the 2 stays where it is, and the negative exponent on the x says move it out of the denominator. Make sure the 2 stays where it is, though, guys. All right, last one is this one. When you have a fraction with a negative exponent on it, what that is saying to do is flip the entire fraction. So this becomes y over x to the to the positive 2, to the 2 like that. And so we're not quite done with this one, because when you have a power out there, this is power of powers property, that can be distributed to both pieces. But the first thing you do, that negative right there says, hey, flip that fraction, and then the exponent becomes positive. All right, and so what this ends up being is y squared over x squared, again, because that 2 applies to the whole fraction. And so your final answer for that one is this right here. All right, last property is rational exponents. And remember that you can write roots as exponents and exponents as roots. So if you have the nth root of x to the m power, that can be written as x to the m over n. So the root goes to the bottom and the power goes to the top. Exponent on top, root on the bottom. All right, it becomes a fractional exponent, a rational exponent. That property goes both ways. So if you have x to the m over n, you can rewrite it as a root. It's the nth root of x to the m. It's just important to remember that it goes both directions. You can take a root and write it as an exponent, but you can also take an exponent and write it as a root. So if I do this example right here, I've got the 5th root of x cubed. This becomes, we want to rewrite this as a rational exponent. This becomes x to the 3/5. The power becomes the numerator of your rational exponent, and the root becomes the denominator. Okay, and if we have x to the 7/8, we can rewrite that as a root. The denominator is your root, so the 8th root of x to the 7th power, like that. All right, guys, let's look at some examples where we have combined things. So down here, this is multiplication. What complicates this a little bit is the negative numbers, but you shouldn't worry about them. Remember that you just group things together. So the -8 and the -3 go together. It's -8 times -3. Right, there's my negative. Then times x squared times x to the 7th times y to the 6th times y to the 9th. -8 times -3 is +24. This is x to the 2 plus 7, y to the 6 plus 9. So 24, x to the 9th, y to the 15th. And that's your answer. Number 2 is our favorite problem. Why is number 2 our favorite problem? Because the 0 exponent, what happens to this term? It becomes 1. And so I don't really have to do any multiplication here, right? Like I got 1 times this thing. So the answer is just 3x to the 5th y squared. That's our favorite, right? That's awesome. All right, this one combines the multiplication of terms with division. Guys, do the multiplication first. Deal with the top first. So it's 6 times 5 times a to the 4th times a squared times b to the 5th times b all over 2a squared b to the 3rd. So that's 30 a to the 4 plus 2 b to the 5 plus 1 over 2a squared b to the 3rd. That's 30a to the 6th b to the 6th over 2a squared b to the 3rd. And then we do the division, right? And so we break that down into its pieces. This is 30 over 2 times a to the 6th over a squared times b to the 6th over b cubed. 30 divided by 2 is 15. This is a to the 6 minus 2, b to the 6 minus 3, which simplifies to 15 a to the 4th, b to the 3rd. Obviously, you do not have to write out all of those steps, right? You can skip these steps, skip the steps that you don't need. But put together the top, put it all together, the top, and then do the division. Or else it's just chaos. All right, let's look at 4. This is a negative exponent, and that negative exponent goes with the term that's immediately to its left, and the thing that's immediately to its left in this case is this set of parentheses, so everything here, okay? And so deal with that negative exponent first. What that negative is saying is, hey, this a cubed b to the fifth, that whole parenthesis needs to be in the denominator of a fraction. So we write it as 1 over a to the third, b to the fifth, raised to the positive 3 power. Positive 3 power. And it's positive 3 because we have moved this to the denominator of a fraction. So this is 1 over a to the 3 times 3, because this is power here, and then b to the 5 times 3. So 1 over a to the 9th, b to the 15th, like that. And number 5 was an example that I did above, but we'll just real quick talk through it again. That negative means flip the fraction. So this is y over x squared, and then distribute that 2, right? So it's y squared over x squared. Again, you guys already saw that. Okay. Let's look at the back. Just a couple more. We've got a couple rewrite as exponential expressions. So instead of roots, I want exponents. This is a square root. What is the root? If it's a square root, what is the number that we use for that root, guys? 2, right? Square root is a second root. So it's an understood 2. And so there is, the 23 doesn't have an exponent. That means it's an understood 1. And so this is 23 to the 1/2 power. And then 15, this is the 7th root of 15 to the 4th power. Again, the root goes in the denominator and the power goes in the numerator. So this is 15 to the 4 over 7. And that's all you are supposed to do with these. You are not supposed to do any calculating, just rewrite. Okay. 8 and 9, they've asked us to write as radical expressions. And so again, root is on the bottom, power is on the top. This is the 5th root of x to the 4th power. And then guys, this is just supposed to be a 3/4. I don't know if that's a negative or if it just drew the line funny, but it's just supposed to be 3/4. So this is the 4th root of b to the 3rd power. All right, let's talk about graphing radical expressions and then solving radical equations. All right, so right here, y equals negative square root of x minus 5. This is a square root function. The parent function for that is centered at 0, 0, goes through 1, 1, and 4, 2, and 9, 1, 2, 3. The dashed line is the parent function. This is y equals square root of x. And so what we do is we use transformations to move this. It has been moved to the right 5 because of that minus 5. It's been moved right 5. And what else has happened to it? What does that negative mean? It's a reflection, right? And so if we take this point right here at 0, 0 and move it to the right 5, you can't reflect something that's on the x-axis. It stays on the x-axis. So this point just moves to 5, 0. But this point 1, 1, if we move it right 1, 2, 3, 4, 5, and then reflect it, it comes down here to negative 1. The point 4, 2, if you move it to the right 5, 1, 2, 3, 4, 5, and then reflect it, it comes down to negative 2. And so our new function is this one right here. Like that. There's a negative. More visible. Okay. Domain of this function, it's been moved right 5, so the domain is 5 to infinity. the range of this function is usually 0 to infinity, but because it has been reflected across the x-axis, it changes to negative infinity first, and then up to the topmost point, which is this point right here. So negative infinity to 0. All right, number 2 is a cube root function. That usually goes through the point 0, 0, 1, 1, and 8, 2. Also negative 1, and negative 8, negative 2. This is our parent function right here. It's our parent function. This one has moved to the left 2 and up 4. And so we just move these points left 2 and up 4. So I'll start at 0, 0, left 2, up 1, 2, 3, 4. 1, 1, left 2, up 4 comes here. Negative 1, left 2, up 1, 2, 3, 4. This point, the 8, left 2, up 1, 2, 3, 4. And then your negative 8, negative 2, left 2, up 1, 2, 3, 4, like that. And this is our function g of x right there that we graphed. What is the domain of any cube root function, guys? Negative infinity to infinity. Always, right? Always, 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 always. And the range? The same. Always, 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 always. Domain and range for cube root functions is always, 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 always negative infinity to infinity. All right. We'll solve 3 equations and then we're done. So guys, this is x minus 4 to the 1/3 is equal to negative 2. That 1/3 means it's a cube root. It's a cube root. And so the first thing that I need to do is get this parenthesis set alone. It's alone. I don't need to move anything. And then what I do is I cube both sides to get rid of the 1/3. Right? And so x minus 4 to the 1/3 power cubed is equal to negative 2 cubed, like that. And these two exponents cancel out. I get x minus 4 is equal to negative 2 cubed is negative 8. I get x minus 4 is equal to negative 8. X is equal to negative 4. Negative 4. Remember that cube root functions do not have extraneous solutions. So while we should always check our answers, we do not have to check and make sure we haven't come up with an extraneous solution. All right, number 4 is a square root equation. And remember that we, first of all, rewrite the root as an exponent. So this is x to the 1/2 plus 3 is equal to 7. Get the thing with the 1/2 exponent alone. And so in this case, we need to move this 3. So subtract 3 from both sides. X to the 1/2 is equal to 4. To get rid of this 1/2 right here, we have to square both sides. And so this 2 and that 1/2, remember that's using the power property of exponents. 1/2 times 2 is 1. And so I just get x to the first power is equal to 16. And since it's a square root equation, we do need to check for extraneous solutions. So we plug in the 16, the square root of 16 plus 3 is equal to 7. 4 plus 3 is equal to 7. That checks out. This is good. All right, this last one is a square root on both sides, which is actually one of the easiest ones to do because I don't have to do any math to get anything alone. I've got a square root on both sides. We can rewrite this as x plus 1 to the 1/2 is equal to 3x plus 5 to the 1/2. And to get rid of those 1/2s, we square both sides. It takes care of both of those exponents. We get x plus 1 is equal to 3x plus 5, and then I just have to solve this equation. So we're going to move the 3x. Negative 2x plus 1 is equal to 5. Move the 1. Negative 2x is equal to 4. Divide by negative 2. X is equal to negative 2. And we have to make sure that we check for extraneous solutions. And so when I plug this into check, I get the square root of negative 2 plus 1 is equal to the square root of 3 times negative 2 plus 5. This is the square root of negative 1 is equal to the square root of negative 1. Can you take the square root of a negative number? Can you take the square root of a negative number? No, we can't take the square root of a negative number. We can't take the square root of a negative number, and so that means that this solution is extraneous. So we need to mark through it, and we need to say extraneous. All right, there we go.